So here's a pseudocode solution, and this already is somewhat Python style, but you'll notice that it is not Python, where we just formally write the description in pseudocode, but that makes already a couple of very interesting and human assumptions that the computer just doesn't have. So we have this iteration up here that says we iterate over a range of numbers from 1 to 100, and the individual number then, of course, is stored in the variable I. And then we'll just write if I is a multiple of 3, then we print Fizz. If I is a multiple of 5, then print Buzz. If I is a multiple of 3 and a multiple of 5, then we print FizzBuzz. And else we print the variable itself. However, this has some, that is the wrong solution, because if we go through this and let's say, okay, 1 and 2 obviously will print I, but let's look at the 3 case. So in the 3 case, we have the first thing here, the first condition here, which is true, so the program will actually print Fizz. And then the I is not a multiple of 3 is not a multiple of 5, so Buzz will not be printed. I is not a multiple of 3 and not a multiple of 5, so this is certainly false here. However, the else case belongs to this if, which means I is printed, so we actually, instead of only Fizz, we get Fizz and 3, because that else case really is being executed. So this is quite interesting, because the way we've written this up really doesn't make or does not take into account the human assumptions that we sort of interpret into this when we formally explain this to anybody else. Because for us it's inherently clear that when Fizz has been printed, then that I should not be printed either. But the computer really doesn't have that knowledge, so it will slavishly just execute everything. So the first if doesn't have an else case, the second if doesn't have an else case, only the third if does have the else case. The if case doesn't hold, so it executes the else case, and therefore we get the print out of the 2. So the same problem, of course, holds for 5, and for 15, it's actually even worse, because 15 is a multiple of 3, so it will print Fizz. It is also a multiple of 5, so it will print Buzz. It's a multiple of 3 and 5, it will print FizzBuzz. So in the case of 15 and all multiples of 15, we get FizzBuzz and FizzBuzz as the output. So clearly the naive write-up of the description of the rules doesn't hold, and some deeper thinking really must be done here in order to get this so that the computer actually executes what we actually want. So that's pretty much what we just found out. And so this is really just a longer description of the cases that I just stated. So this is really the description of the wrong output.